Good morning, friends. Today we are going to see some MCQ on first law of thermodynamics. So let's start. First question is, the first law of thermodynamics is a statement of. The first law of thermodynamics is a conservation of energy because it states that energy can neither be created nor destroyed, only transformed from one form of energy into another form of energy. It shows the conservation of energy. So first law, so option number B is the correct answer. So next question. Question number 2. The mathematical form of the first law is, so delta Q equal to delta U plus delta W. Delta Q is a heat energy. Delta U is the change in internal energy. And delta W is the work done. So if change is small, then delta can be replaced by D. So dq plus du plus dw, option A is the correct answer. So next question. In the equation of dq equal to du plus dw, dw represents. Suppose this is a system. Gas is contained in a container. If we supply heat, then internal energy increases and gas expands. So work volume get increase. And expansion takes place. So work done is positive. In case of expansion, work done is positive, means work done by the system. It's shown by positive sign. That is the positive work done. If compression takes place, then work done will be negative. That is the work done on the system. It's shown by negative sign. So this is the sign convention. So dw is the work done. If work done on the system, it will be minus negative. But in this equation, it is a positive. Positive sign means work done by the system. Work done by the gas. Okay. So option B is the correct answer. Next question. For an adiabatic process, the heat transfer is, heat transfer will be zero. Because in case of adiabatic system, container is completely insulated. Gas is there. So system, in between system and surrounding, there will be no heat transfer. In between system and surrounding, there will be no heat transfer. Okay, so heat transfer will be zero. Next question. Which process occurs at constant temperature? If temperature is constant, that is change in temperature equal to zero. So that process is known as isothermal process. In that temperature is constant at both state and change in temperature will be zero. So next question is, in an isothermal process, change in internal energy will be. In case of isothermal process, temperature is constant, change in temperature will be zero, and internal energy is directly proportional to temperature. If change in temperature will be zero, then the change in internal energy will be zero. Option A is the correct answer. Next question. In an isochoric process, the work done will be. Isochoric process means change in volume equal to zero. Volume remains constant. Work done formula is work done equal to pressure into change in volume. If change in volume equal to 0, then work done equal to 0. So work done equal to 0. Option A is the correct answer. Next question. In an isobaric process, the heat supplied equals. Isobaric process means pressure is constant. So we have first law of thermodynamics. First law of thermodynamics. So heat supplied equal to change in internal energy plus work done equal plus work done. So option C is the correct answer. So heat supplied equal to increase in internal energy plus work done. Work done takes place. So at constant pressure, heat supplied increase both internal energy and does work. So next question. Option B, C is the correct answer. Next question. The first law of thermodynamics fails to give information about. The first law of thermodynamics give. So heat supplied is used to increase internal energy plus work done. It doesn't give any direction. It gives only conservation of energy, but it gives heat work relation, internal energy given, but direction of process not given. Direction of process not given. In this equation, we can't find any direction of process. है ना? It shows the energy conservation, heat work relation, and internal energy. It shows, but direction of process it don't give this equation. So option B is the correct answer. Next question. The SI unit of internal energy is joule. Next question. We have some things we have to remember. In cyclic process, the net change in internal energy is. In cyclic process, so at initial and final state. In case of cyclic process, at initial and final state, temperature is same. Temperature is same. So temperature, internal energy is directly proportional to temperature. We know that internal energy is directly proportional to temperature. If temperature is same, then internal energy also same. And change in internal energy will be 0. Change in internal energy will be equal to 0 because change in temperature equal to 0. Change in temperature equal to 0. So change in internal energy equal to 0. We can represent as pressure and volume graph. This is the way. Suppose this is 1, 2, 3, 4 and direction of process is 1. This is the way at initial point, at initial state and final state, pressure, volume, and temperature are same. Pressure, volume, and temperature are same. If temperature is same, then change in temperature equal to 0. So internal energy also equal to change in internal energy also equal to 0 because internal energy is directly proportional to temperature. If change in temperature 0, then change in internal energy also equal to 0. So option C is the correct answer. Next question. For an ideal gas, internal energy depends only on. For an ideal gas, internal energy depends only on temperature. Internal energy is directly proportional to temperature. For an ideal gas, internal energy is directly depend on temperature. Next question. The work done in an isothermal expansion of an ideal gas. We have formula work done equal to. We have formula. What happened here? Uh, Okay. The work done in an isothermal expansion of an ideal gas is, we have formula work done equal to nRT ln Vf upon Vi. This is the simple formula we have. where N is the number of moles, R is the universal gas constant, T is the temperature, Vf is the final volume. This is the initial volume. By using this formula, we can find out the work done in case of isothermal process. In case of isothermal expansion, we have this formula. We have to remember this formula too. So next question. Option B is the correct answer. Next question. The first law of thermodynamics is equivalent to. The first law of thermodynamics is equivalent to law of conservation of energy. Law of conservation of energy. Next question. When gas expands adiabatically, its temperature is. When gas expands adiabatically, its temperature is. Since no heat supplied in case of adiabatic process, since no heat is supplied, gas does work at the expense of internal energy and lowering the temperature. Acha, temperature. When a gas expands adiabatically, its temperature will be. ठीक है. We have first law of thermodynamics. Delta Q equal to delta U plus delta W. So in case of adiabatic process, delta Q heat transfer between system and surrounding is zero. Heat transfer between system and surrounding is zero. So 0 equal to delta U plus delta W. In case of expansion, work done equal to work done is positive. In case of expansion it says no expansion. So work done is positive and internal energy will be negative. If change in internal energy is, this is the negative sign shows decreasing internal energy. Negative sign shows decreasing in internal energy. So temperature also, because internal energy is directly proportional to temperature. If internal energy is decreasing, then temperature also decreasing. Because internal energy is decreasing. So option B is the correct answer. So we can stop here. So thank you very much. Is there any question or any comment? Please let us know. Okay. So stop here.